Hello everyone. Today we will be discussing about the IBP history cleansing. This history cleansing is one of the important steps for a demand planner to carry out demand planning. This is a simple flow chart wherein the sales history, which is captured in the S4 in the ECC from actual sales order, the actual shipment history, is moved into SAP IBP through a platform called as HANA Cloud Integration, or the CPI. The actuals quantity key figure in the SAP IBP stores the sales history value. During this scenario, during today's demo, we'll be discussing more about why history cleansing, why it is required exactly, and different ways of history cleansing, what are the different algorithms are there in the SAP IBP to carry out the history cleansing process. And when we compare non-cleansed history forecasted data against cleansed history forecasted data. So let's go into the system and see how do we carry out history cleansing. Now, this is the app, Manage Forecast Model app, where we create models. So this history cleansing is one model that is created in this app. We'll go inside this model. This is a general information which is required. We'll be looking into a past 12 weeks of data, and we'll be forecasting for the next 54 weeks in the future. So this is the pre-processing step wherein we define the steps in order to carry out this process. But first, why history cleansing? So suppose my historical data didn't capture in some of the periods any values, then will it be good to carry out my forecasting depending on those values with the missing values? It depends. Again, in some particular period, due to some technical or some manual intervention, the historical data for a particular period has a very inflated number. So will it be good to carry out a stat forecast based on those figures, those erroneous figures? Or in some period the sales have carried out much larger as compared to the other periods. So removing those inflated numbers or removing those missing values by replacing a given value, the stat forecast will give a better picture. The accuracy will be higher, the error would be less. It is not necessary to carry out a cleansing process for the actual history, but it is recommended to actually remove the outliers if there is any, to replace the missing values with a given value if there is any, so that a better picture of a stat forecast is resultant of the stat forecast model. Now we will look into some of the models. So here are three different models, three different algorithms that are provided by the SAP for history cleansing process. Not necessarily a history cleansing process, it can be used to cleanse out any data of a key figure. If suppose an output of a key figure is having some missing values, but a planner doesn't want any missing values there, they can carry out this process for that particular key figure also. So it's not necessarily for history, but here we are demoing it for historical values so that we get a clear picture of a stat forecast. So what all available algorithms do we have? We have substitute missing values. So this algorithm is necessarily for when a planner wants to replace the missing values with a given value or with any other option such as a mean or a median, then the planner can use this available algorithm. Then there is an outlier correction. When there is an outlier in the data pattern, then we can replace this outlier with a given value or with a tolerance value or with mean, median. We'll have a look into those available options. Then we have a promotion sales lift elimination. Suppose a demand planner, before doing a stat forecast, wants to remove any promotions from the historical data. They can do that with this available method. In today's session, we will be focusing more on the substitute missing values and the outlier correction. I have selected a substitute missing values. And the method used for substitution is mean. You can choose a median, you can choose a given value. When you choose a given value, another line with the value for substitution a mandatory field will pop out. Here you can place any value for which you want to replace it, any value you want to insert it in the missing value place. Then there is a time scope of substitution. It can be a full horizon, that is the past and the future, history only, and the future. Now for the future, suppose if there is a key figure which is having some values and in some particular period the values are missing, then a planner wants to insert those missing values with some given value with another value, then they can use it for a future. But since we are using it for a history cleansing process, we will use history only. We'll replace it with a mean. The input for algorithm. Now the actuals quantity that is the quantity from the legacy system or the ERP system S4 ECC. The values will be from the ECC system or the ERP system. Now we will take this actuals quantity as an input into this algorithm and will save the result in actuals quantity adjusted. So this will be a system output key figure, wherein this particular key figure will go in the algorithm and it will save the result after removing those outliers or any missing values. So the cleansed data, the output will be saved in this particular key figure and we will save it. So let's go into the planning book. This is our simple planning book. We have a product, 2 DC and 2 customer. Now as you can see, the product DC2 and customer 1 is having few missing values in my past. So a planner wants to insert a value over here so that they do not have a missing value in the key figure, which will be taken in as an input for my stat forecast. So I will carry out the task. This is a run stat forecasting. I'll select my particular set of data, remove the rest, and the customer. Now I have this set of data. I'll be removing the missing values. So I will take this as history cleansing, since my model name is history cleansing. Method used for substitution is a mean. I'll select the unit of measure ID here and next execute it. Let's see the status. The status looks in process. Refresh it and it's done. So I'll refresh the planning book. Look, the data is now populated. In place of a missing values, we have now mean of the data. So this is how the algorithm works for the missing values. This is very helpful for removing the missing values. There can be a value also which a user wants to input. Let's take that example also. With a given value, we'll make it as 15 and save this. Let's execute it again. Select your data, my operator, next, execute it, and the status, yes, it's in process, it's finished. Let's refresh the planning book. Look, now it has been changed to 15, the one which was given by the user. So this is very helpful when you have a lot of products, product family, lot of SKUs at different location, different customers. So this algorithm is very important in order to cleanse your historical data or any key figure data, whether it is in the past or in the future, or if you want to carry this out for the full horizon. So this is a very useful algorithm provided by the SAP. Now let us look how to remove this outlier. You can see in the data, this clearly depicts the outlier. If I want to remove this outlier, I'll have to carry out one of the process. So let's go and see if I have a model. Yes, I have a model here. We will look into the historical period of 52. Let's make it 12. Okay, now outlier correction. So there are two algorithms, interquartile range test and variance test. In the interquartile range test, the system checks whether the time series values are within the interquartile range, which is the difference between the third quartile and the first quartile. So the system, when finds that the data is above the upper bound, or if it is less than the lower bound, it replaces that value with a user input, or with the limit, or with a mean or a median. So you have different options. So suppose the options are here: no correction if you want to leave it as it is, correction with mean excluding outliers. In this case, the outliers, after removing the outliers, whatever mean of the remaining data set, the mean will replace the value where you have an outlier. Correction with tolerance. In this case, the system will recalculate the tolerance level and it will replace the outlier with that particular tolerance level. So same with the median. You have a multiplier over here. So this multiplier is actually useful in order to calculate the upper bound or the lower bound. So once you calculate the interquartile range, that will be multiplied with the multiplier value and deducted or added to a quartile 1 or quartile 3 in order to get the lower bound or the upper bound. This is generally kept as 1.5 or 3, but this is editable and we can replace it with some other value as well. So the input for algorithm is actuals quantity and the output will be saved in actuals quantity adjusted. So let us save this model and let's go into our system. So look, here we have this 1005 as an outlier. So system will detect this and will replace it with the value, with the mean of all these figures excluding my outlier value. So let's see how it works. Go to start forecast, select my filter first, carry out for my product 1, DC1 and customer 1. Go into the definition, outlier correction, because this is my model name, outlier correction. I'll select the unit of measure. Next, execute it. Okay, let's check the status. It's in process, refresh it, and it's finished. Because of the HANA cloud, the jobs are too fast. It takes less time to execute. Look, the data has been replaced with the mean excluding the outlier. However, if I change this to correction with mean only and save this, it will take the outlier as well into account and replace this value with the mean of all these values. So let's see. Start forecast. Again, my filter. I'll remove these products. This 3. The definition. Outlier correction. Each is next. Run. Okay, and let's see the status. Yes, it's in process. Finished. Refresh my planning book. Look, the value has been changed to 93. Here is the average. It has been changed to 93. So this is how the algorithm works, and this is very useful algorithm for a demand planner to get the true forecasted data. Now we will see how, and if we use actual quantity, that is a data without outlier correction, if we feed this particular data into a stat forecast model, how will it look like when compared to an actual quantity adjusted, that is the data after removing the outliers and sending it to the stat forecast. And we'll see how the data differs. In this way, you will also get to know why history cleansing is so important for a demand planner as a pre-process step or as a first process before he or she carries out stat forecast. So let's look into the model that I have. So I'll use a simple model, that is the simple average model. So let's see if I have, yes, I have built one. I have a simple average model over here. So it will only take a simple average. You can work out with the different models that is available with the IBP. So for an understanding process and for clear comparison, I'm using the simple average. So here my main input will become actual quantity, because that's a key figure which holds the data without any outlier correction. My output will be saved in statistical forecast quantity. I'll save this model. I will run the stat forecast for my particular set of data. So let's take this only, the same thing. Yes, and I'll select my forecast model, that is the stat forecast, and I'll run this. The job has been executed. Let's see the status. Checking the status is an important thing, because here if you download this thing, it will give you the picture how it has been carried out. Let's refresh it. Let's refresh our planning book. Now the stat forecast has been carried out. Let's see in the worksheet stat forecast monthly. I'll just readjust my planning book. Okay, I'll remove this unwanted key figures as of now. So all filters selected. Let's click OK. And here is my planning book. So you can see the stat forecast has been carried out and it all shows 93. Why? Because if you remember, I have taken this particular key figure as an input. So my outlier is also there, which has been taken as an input for my stat forecast. So let us carry this stat forecast without taking this outlier as an input. What I mean to say is, we'll take this as an input for the stat forecast model. I'll change here. I'll take this actuals quantity adjusted as the main input for my forecasting step. I'll save this and will execute it. So let's take stat forecast. I'll select my filter. Okay, run, and it has executed. Let's check the status quickly. Finished. Refresh it. Look, the value has changed to 17. So this is why it is very important to remove the outlier before we carry out the demand planning or the stat forecast generation, because it gives you a better picture of a forecasted quantity. The forecasted quantity forms a very important for a demand planner, because the sales and the marketing people will be giving their input based on the forecasted quantity. All your sales, delivery, the procurement, the production planning will be carried out for the future. All your planning will happen based on the stat forecast quantity. So it is very important for a user, for a demand planner, to get a clear picture, to get a good picture of a stat forecast quantity. Therefore, it is always recommendable to have a history cleansing or an outlier correction or a missing value removal, so that you have a good historical data which can be fed into stat forecast model and generates a good picture of stat forecast quantity. So that's it for the today's video. Hope you all have enjoyed it. We'll see you with the next video soon.